So, in case of algebraic expressions, uh, let us say we have, before going to algebraic expressions, just revise because already 3 days are finished. So, I want just to revise the things that till now we had learned, right? So, whatever the numbers are there, if we want to divide, so generally we write in this fashion. Whenever for simple numbers onwards, I am starting. So to take the examples easily. So 7, 6, 4, 5 is there divided by 4. So we have 4 ones are 4, 36. 4 nines are 36, 0. 4 ones are 4, 0. 4 ones are 4. 1 is my remainder. So this is the first procedure we had learned. And then when it is a double digit divisor, let us say 7, 6, 5, 9, 4 divided by whatever 62. So because this is 62, it is better to write 7, 6, 5, 9, 4 separately divided by 6 and 2 here. So first one is 7. So dropping down 7, 7, 6 ones are 6. So the number is passed as 10 because when 7 is divided by 6, 1 is my quotient and 1 is my remainder. Then 10 plus 6 minus 2 because here we are multiplying this and then getting this. So 14. So 6 2s are 12, 20 passed. And 2 into 2, 4 is subtracted, 21. 6 3s are 18, 30 passed. Right? Beautiful. 1 10 is passed, 2 20 is passed, 3 30 is passed. 3 2s are 6. 39 minus 6 is 33. Right? Now 6 5s are 30. 30 passed and 5 2s are 10 is subtracted. So 24 is my final remainder. So if I want decimal place, just put zeros and put decimal place and continue the procedure. If I want to find the digital root for this, it is 8 here, 5 3 1 cut, so 2 here, 6. So 8 2 is 16 means 7, 7 and 6 is 4. So the final one should be 4 because 16, this is multiplication and this is addition. So 16 plus 6, 22, which is 4. So 5 cut, 9 cut, 5, 6, 7 cut. So 4 remains. So 4 is my verification, digital root is verified. So my answer is correct. Now participant has requested, let us see that. So here 7, 6, 4, 3, 6, 5, 2. Divided by 634. So we write 6 here, 34 here, right? So because 2 flag digits means here we are leaving 2 digits. Before 2 digits we demarcate so that this part only is our quotient and this part will be our remainder. So first one is 6 ones are 6, 10 passed, and then 7, 6 ones are 6. So here 3 and 4 I am subtracting separately, right? So minus 3 minus 4. So 16 minus 3 is 13. So already 0 is there. If something more is negative pass, so then it will be difficult. So 10 is there, 10 minus 6 is fine. So I will go for 2. 6 2s are 12, 10 passed. I hope everyone is clear till this point. So 6 2s are 12, 10 passed. And because 2 has to be multiplied, 2 3s are 6, 2 4s are 8. Now, this 10 and this 10 cancels, only 4 remains. So 6 0 0, 10 10 cancels, so only 4 remains. So 6 0 0, 40 passed. And here 0 0 I am adjusting. Now 43 minus 8 is 35. So 6 5s are 30. So 50 passed. And 5 3s are 15 is bar. And 5 4s are 20 is negative. So 56 minus 15 is 41. So here 6 6 are 36, 50 passed. And then 6 3s are 18 has to be subtracted. And 6 4s are 24 need to be subtracted. So 55 minus 38 is 17. So out of that 17, I am writing 1. 55 minus 38 is 17, 1 and 70 pass. 72 minus 24 is 48. So 12056 is my quotient and 148 is my remainder. If I want to check the digital root, 6 and 3 cut 4 is there. 5 3 6 3 cut 5 is there. 4 5 are 22. 2 plus 4 is 6. So the final digital root should be 6. So leave 6, you can cut all others. 6 plus 3 is 9, 5 plus 2 is 9, 2 plus 4 is 9. So 6 is 9.
Please mute all, sir.
Yeah, sorry. Yeah, I think Charan had taken care of that. So I hope everyone is clear with this problem the way that I am solving it, right? So here, whatever the big division, if you follow the procedure, that's it, means our answer is there. The more the bigger divisor, the easier the problem it becomes, right? So the beautiness here is how to do this without writing all these steps. Without writing all these steps, how to do this. That is the beautiness. So we will see that and we will move on to the algebraic division. 7 6 4 3 6 5 2. So the same procedure, just I am taking 6 1s are 6. Okay, be very careful, full attention here only. You have to be very careful because I'm not writing anything extra. So everything is happening in the mind. Our mind
632.
is very powerful. If you tune it in that direction, it will start working.
632.
So let us see that if I'm passing here, means I will write something. It is not that I don't write anything. So 10 is passed and minus 3 is subtracted. Only one number is subtracted. So this is 13. So 6 2s are 10. Sorry, 6 2s are 12. So out of 13, 6 2s are 12. 1 remains passed as 10. Now here it is very important. 34 and 12 cross multiplication. 6 plus 4 is 10. So 10 is subtracted here. This 10, the cross multiplication, where 3 and 4 are the flag digits, 1 and 2 are the quotient digits. So you have to be very careful. The second subtraction that I am doing, the first subtraction is very easy. 1 into 3 is 3. The second subtraction onwards, it is very, very important. In the second subtraction, it is a cross multiplication. I'm subtracting 10. So I'm getting only 4 here, right? So 600, 4 passed as 40. Now you have to take 2 0 and 1 2 and then again cross multiplication. So it is only minus 4. So my number is 39. Do you observe? This corresponds to this, right? So 39. 39, 6, 6 are 36. 30 remains. Now again 0, 6, 1, 2. So you have to subtract 6. Something went wrong?
Crisscross 1 2 tona 3 4 tona sir?
Yeah. Sorry. 3, 4. Sorry. Before one also it is wrong. 2, 0, 3, 4. I would have taken 3, 4 on the downside. Okay. 2, 0 is there. 3, 4 is there. So 8 is subtracted here. Sorry. So 43 minus 8 is 35. So 6 5s are 30. 5 remains. 5 passed as 50. So 43 minus 8 is 35. 6 5s are 30. 5 remains 50. So now it is 0, 5. So 0, 5, 3, 4. So 15 has to be subtracted. So it is 41. So 6 6 are 36. Again 5 passed. So here my division process ends. So here 56, 34. So 20 plus 13. So 20 plus 18, 38. So if I am subtracting 38 here, 17 will be there. 170 passed. And the last subtraction is 6 times, last is 6. The last digit is 6 multiplied by the last digit 4. So 4. So when we are multiplying 6 by 4, 24 you subtract, it is 48. So 12056 is my quotient and 148 is your remainder. So just all these things also I'm writing just because to show it to you. Otherwise, we can do it mentally. We can train our mind in such a way that the maximum possible digits are this one, and doing the cross multiplication. You have to start with single one and then keep on increasing the multiplication as we do the multiplication, right? In multiplication, what is the first step? If I want to multiply 6, if I want to multiply 12056 multiplied by 34, right? So the first multiplication is 1 times 3, right? So with that we will start, and second multiplication 1 2 times 3 4, and third one is 2 0 times 3 4, and fourth one is 0 5 times 3 4, and then we do this, and then the last one. So accordingly we are going to subtract these things, and then our final answer is there, right? So the last one will be, it starts with single multiplication, it ends with single multiplication, always. Either on the right hand side, if we have 3 digits, 4 digits, 5 digits, any number of digits, it is the just multiplication process. Think about the multiplication process of this. I hope many of you know the multiplication process of this. If you don't know it, then actually I would have taken the different step, but this is how you have to do it. So if you go with that method, you don't find this, but if you want to write the answer in one line, so it is important to follow this procedure, and then you are solving it, right? So 12056 is my quotient and 148 is my remainder. Repeating this problem. We'll take another problem rather than repeating it, right? So yeah, another problem I will take so that it will be easy for people to observe, right? So you can give me any number, that is digit 7-digit number. You can write it in the chat box, any digits by any digits, it doesn't matter, right? So you can give me any number, no problem. Somebody is giving me the numbers. Please write in the chat box. Any 6-digit number, 7-digit number, anyone? No? Yeah. So, okay. 1, 2, 3, 4, 5, 6, 8, 9. 1, 2, 3, 4, 5, 6, 8, 9. Divided by 7, 8, 6, 5. Divided by 7 becomes 8. 86.5 I change it to 86.5 I change it to 1 3 bar 1 bar 3 bar and 5 bar, right? So that all goes as positive only, so I need not worry, right? So instead of 7865 I'm taking like this. Here the beautiness is I'm going to write only in one go. So my quotient is till this part. This is my quotient part where 4 digits I'm going to get, and remaining is the remainder part. Okay. So every time we are multiplying, whatever the quotient digit is there, that will be multiplied with this flag digits 1, 3, 5. So keeping in mind, be very attentive. Yesterday we learned the method that is very simple. So the simple one, we are making it little complex and applying our brain and simplifying the things, right? So just observe. Don't do anything. Just keep observing exactly what I'm doing. So the first one is.
Hello, sir.
Yes.
Sir, how can we know last 3 digits remainder?
Here 3 digits are there. So last 3 digits.
Last 3 digits.
Based on the number of digits in the divisor. You remove 1 and remaining digits will be the number of digits in the remainder.
Okay.
Okay. So that is the rule. So here we are taking first 12 by 8, right? So I will write with different colors. It will be easy. 8 ones are 8, right? So 4 passed as 40. Now 1 is multiplied with -1 here. This -1s I am taking here, -1. So 1 into -1 is -1. It becomes +1, right? So here 44. The next term is 44. So 44 I am taking with 44. I am doing with again 8 only. The divisor will be 8. So in the second step, 8 5s are 40. 4 remains passed as 40, right? Now I take 1 5 1 3. Now 5 plus 3 is 8. Here I am going to add 8, right? Because the cross multiplication, 5 ones are 5, 1 3s are 3. This 1 and 5 are first ones, and below bottom one are 1 and 3 from the flag digits. From here, the 1 and 3 are coming here, right? So 44 plus 8 is 52, right? 44 plus 8 is 52. So now this 52, we are going to divide it by 8. This 52 is divided by 8. So the next digit we have to be little cautious because 3 multiplications are going on. So it's okay. We can adjust later also. We'll go ahead. So 44 plus 8, 52, 8 6 are 48, right? 8 6 are 48. And then 40 remains, right? So now here 1 5 6, here 1 3 bar 5 bar, right? So now it is a cross multiplication. So 5 plus 6 11 plus 15 26. So my addition will be 26. So it is my 71, right? 45 plus 26 is 71. Here I can go with 8 9s are 72. Here I can go with 8 9s are 72 minus 10 is passed, right? So my now three digits are 5, 6, 9, and -1, -3, -5. So when I'm doing the cross multiplication, 25 plus 9, 34 plus 18, 52. That's it? No. 135 only. 25 plus 9, 34 plus 18 is 52. So here 52 I'm adding it. So 52 plus 6, 58 minus 10, 48. So 4 remains, 80 passed. Now only two multiplications, 6 and 9 minus 3 minus 5. So automatically it will be added, so we don't worry. If it is going beyond this 48, here better to write instead of 48, wait. Before writing 48, I will take this 48 as 50 minus 2, which will be easy for me because already big multiplications is going on. So I will take 6, 9 minus 3 minus 5. So 30 plus 27 is 57.
Sir, excuse me, so 48 ante 6 times పోతుందా sir?
So 48 is written as 50 minus 2.
No, నేను అంటుంది అది మనం 8 తో డివైడ్ చేయాలి కదా.
No. This is the remainder part. This dotted line is there now. We don't divide anymore.
Okay, sir. Sorry, sir.
So just we pass it. We are not dividing anymore. So it is just passing and getting the final remainder.
Sir, ఇక్కడ 9 కూడా చెప్పండి సార్ మళ్ళా. 9. 40 plus 5 plus 26. 71.
71. So 8 9s are 72.
Yeah, okay. 8. Okay.
8 9s are 72.
I think
minus 10 is
6.
passed. Right? So you have to be very careful where exactly you are going. So our mind, it is capable of doing all these things in the mind only, right? So just this I am writing for you to understand. If I am not writing this, it is very difficult for you to understand, right? So 65 minus 20, 45. So 45. So 45 plus 9 plus 45. It's okay. 90 plus 99. So here we are getting 57, 65 minus 20 is 45. 450 passed. Yeah, it is also difficult. 450 passed is difficult. So here we are getting again 45. 45 is written as 50 minus 5. Because the last digit should be a 2-digit number. So to avoid the negative, I will write in this fashion. So 5 and minus 50 passed. So the last multiplication is 9 into 5. The last multiplication is 9, 5. So 9 5s are 45. 45 plus 9 is 54. Minus 50 is 4. So 5504. It has to be a 2-digit number. The last part must be a 2-digit number. So my answer is 1569 is my quotient. 5504 is my remainder. When 7865 is divided, means 1, 2, 3, 4, 5, 6, 8, 9 is divided by 7865. Right? So observe, first one is 12 divided by 8. We are writing 1 and passing 40, and 1 into 1 is 1, which will be added here. 44, 8 5s are 40. Highlighter I will take 1 second. Here 44 divided by 8, 8 5s are 40. Again 4 remains passed as 40. Here again we are doing 1 5 and we are taking, and 1 3 we are taking from here, and then cross multiplication, which is 8. So 1 5 1 3, which is 8. 44 plus 8 is 52. 52 is divided by 8. 8 6 are 48. 4 remains 40. So now in the third one, here 1 5 6 is there and 1 3 5 are there. So it is 3 combinations. 5 plus 6, 11 plus 12, 15, 26. So 45 plus 26 is 71. So when 71 is divided, yesterday I told, if it is remainder is more than half, that is 40, say if it is going beyond 40, I have to be more careful because the remainder is 7. Here instead of taking 8, I will write 9. So here I am getting 71. 71 is divided by 8. 8 9s are 72. Minus 1 passed as minus 10. Here 569 is taken and 135 are taken and cross multiplication. 25 plus 18 is 43 plus 9 is 52. So 52 plus 6 is 58 minus 10, 48. So 48 because the next digit should be a 2-digit number. If I'm writing this, it is going to be a 3-digit number. So I write 48 as 50 minus 2. 5 is retained here and minus 2 is passed as minus 20. So the next multiplication again, because 6 9 are left, 6 9 3 5, 6 9 3 5. So 30 plus 27 is 57. 8 is 44, 65. 65 minus 20 is 45. So 45 is written as 50 minus 5 because last digit, all these positions you cannot have 3-digit number. So to maintain the 3 digits, we pass this negatives, right? So 5 is written here, is passed. And then 45 plus 9 is 54. 54 minus 50 is 4.
Hello, sir.
Hello.
Hello. Hello.
Hello.
Hello, sir.
Yeah.
Sir, just repeat remainder part only, sir.
Remainder part 8 9s are 72 minus 10 is passed.
Okay, sir.
Right? So here each part should be a 2-digit number only. You cannot have 3-digit. If you are having 3-digit, 1 digit has to be passed to the left.
Okay, okay.
Okay. So because of that, here we are getting 48. But 48, if I am passing 80, 80 plus 57 is going to be more than 100 or less than 100?
Yes, sir. More than 100, sir.
More than 100. So beyond 3-digit, I don't want. For that sake, I am changing this 48 as 50 minus 2.
Okay, okay.
So here 48 is there. I am writing it as 50 minus 2 is passed as minus 20. So after simplifying this, 57 we are getting here. 57 plus 8 is 65 minus 20 is 45. If I am passing 40 and 4 if I am writing and passing 50, 59 plus 45 is going to be more than 100.
Yes, sir.
Right?
Yes, sir.
So to avoid a 3-digit number, again 45 is written as 50 minus 5.
Sir,
Is written as,
sir, 1 minute, sir. Sir, multiplication, sir. 569 135. You are taking 569 135, and again 69 35. So why you are taking like that, sir?
which one? Here?
Yes, sir. Sir.
In this below multiplications you are talking about?
Yes, sir. Yes, sir. Last one, sir.
Yeah,
Five,
the
six.
last one. See, when you are doing, I don't know whether you know the general multiplication of here or not. So when 1569 is multiplied by 135, right? So the first step is 1 into 1. The second step is this. The third step is this. The fourth step is this. Fifth step is this. And sixth step is this. So there are 6 steps here, right?
Okay.
So this is the first step. This is the second step. This is the third step, and so on till 6th step, right? So this includes.
Okay,
Right?
thank you. Thank you, sir.
So because of that 6 step, the 6 steps are adjusted here accordingly, and the remainders are adjusted accordingly here. So these are all happening in the mind only. I am showing it to you just because without writing this, it is very difficult for you to understand, right? If I have to do on my own, I can do this without writing anything on the board. Directly the answer I will write 1569 is my quotient, 5504 is my remainder, right? So it is possible. Only the thing is you have to tune your mind in that direction. You have to observe what all the digits are coming, which one you are multiplying, how you are getting the next digit, what is your next partial dividend, which one you are dividing, and whether positive passing or negative passing. All these things you have to keep it in mind. So many calculations are happening in mind, and we are arriving it to the direct solution. So it is not a magic. Suddenly Ramesh is coming and telling the answers. it is lot of internal calculations are happening. Generally, when I take the teachers training classes and all in art of living, we used to almost when I do the calculations, it's almost 30 to 40 calculations are happening in the mind. So this into this into this, plus this into this into this, and all. So it is multiple operations, multiple things, and only happening in the mind. Directly, we are writing the answers. That's it. So it needs little training. You should know the logics here, how it is happening. And the second is training. So both should work. You should know the procedure exactly how we are doing it, right? At the same time, you're going to apply the logic and simplifying the things. I hope to some extent, I don't say that it will be really tough, right? So first time understanding these things, but you can practice. What I want to say is here, I'm not telling you that first time you will achieve. If you are achieving it is good. Don't worry. If you are not achieving also, practice makes you perfect. So just follow the procedure. Make sure that all you are not exceeding, because all are negatives. So exceeding the divisor is a problem, right? Here 71 is there. If I'm taking 8, here it will be more bigger numbers will come. So which will be more than 7865, right? Now if I want to verify this as a digital root, my answer is right or wrong. So let us see what all will cut. 4, 5 cut, 6, 3 cut, 8, 1 cut, 9 cut. So final digital root should be 2. 5 cut, 6, 6, 12. 12 is 3 here. 5, 4 cut, 5 is here. So 3 into, oh yeah, here. So 5, 6, 7 cut, so 8 here, right? Divisor into quotient. So 8 into 3 plus 5 is equal to 2. So 8 3s are 24 plus 5, 29. 29, 9 cut, so 2 is matched, right? Wow. After doing this much, we are directly getting and verifying. And I'm telling that my answer is sure, right? So it is really wonderful, right? So, but needs a lot of practice. I'm not telling that just by practicing your division is improving. The more important thing is the thinking is improving. Do you observe? The way that we are thinking, the way we channelize the things, the way our capacity of mind, that increases. Don't think about the division. Thinking, okay, that is anyhow happening. That is a byproduct, I say. But the more important thing is you allow your mind to work in this direction, right? You are not allowing. No, 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 it is very difficult. I can't do this. That's it. You full stop. Your mind will never grow from there, right? So it may happen some mistakes. You may do it. It's fine. It's okay. As you practice, your mistakes will be reduced. But if you see that, Ramesh, this is very difficult, I cannot. See, the process is very, very systematically designed. So you are observing many things in many different directions and you are writing the numbers, right? So I hope to some extent, I don't say that, but to some extent we can see that directly we can write for any number just like that, right? So it needs the internal calculation, subtraction, addition, passing remainders, how you are calculating it, and all those things are very important. You have to go step by step. So you should not do everything in one go, step by step. You calculate everything in the mind but step by step. First you go with this and then go with this and then go with this. All the cross multiplications, everything is happening in the mind. So you have to be very, very careful while solving this, right? So please be very careful, and then your mind is very powerful, I'm telling you, right? So it is more important not to solve the problem. It is more important to improve your brain capacity, your thinking capability, right? So, and the thinking capability will not limit to only mathematics and Vedic mathematics. It will be in any work you do, you start thinking in this direction, right? So that one is very important. That one changes the whole perception of Vedic mathematics. The main, according to me, there are two things. One is the simplest way to solve any problem in one liner to great extent, minimum possible steps. I don't say that it is one liner. I can say that it is minimum possible steps that you can write is the Vedic method. The sutras are written in so versatile, means you can apply it anywhere to any problem. So the sutras are so well designed, right? So don't worry about the sutras part, but what I'm telling is it's very important that whenever any problem is there, the simplest way to solve is Vedic method. Some of the other sutra you can apply, right? So that is the first thing I want to tell you. And the second and foremost important thing is it's not that just this process is happening. Your mind is trained in this direction. So once your mind started training in this direction, you start doing multiple things in one go, right? So many steps in one go, right? Hope I don't want to give much lecture on this. Let us go ahead. Now, today topic is division. So once this division is completed, almost my algebraic division is also completed. So let us take few problems related to algebraic division. First, let us take very simple ones, right? So let me take something like that, something like x square minus 5x plus 6 divided by x minus 2, right? So if this problem is there, so what I'll do is generally whenever I have to divide this, anyhow the first question, but the thing is if this is 1, so you are going to add 2 at every position, in the sense that 1 minus 5, 6 is there. Whatever the digit is that is there, x minus 2, so is equal to 0, you can keep it if you want, but basically you have to add 2 at each position. So no. You have to multiply with 1 and then add accordingly. Sorry. So here 1, we write it as 1. Here 1, 5, 6, how we are getting? So generally we write like this to make it easier ourselves. So this is called also as our, the division process is called okay. So here 1 we are dropping down as it is, right? And then 1 into 2 is 2 here. So minus 5 plus 2 is minus 3. So I'm multiplying with minus 2 here, and then adding it here. So minus 6, 0. So x minus 3 is my quotient here. The most, this is the, when the single digit here, x minus a or x plus a is the divisor, right? So you are taking x plus a is equal to 0 or x minus a is equal to 0, and always you multiply and write it. Always you multiply and write it. So if you keep on adding this, your answers are there. Okay? So this is same as the general method. Let me go ahead and take the general method. Now let us take something like okay, anyhow. First, let us start with 1 digit only. Let us do slowly. Okay. I hope everyone little bit clear about this, although I had jumped to a good extent, but I think everyone is clear with this. Let me take one more example so that it will become much more easier for us. Let us say my number is 7x squared plus 5x plus 3 divided by x minus 1. So generally we take 7, means because the 1 is there, so always we take the digit and multiply with this and change the sign and write it. So 7 plus 5 is 12, right? So 7x plus, so you write 7 into 1 is 7, 12. So 12 into 1 is 12. You are writing again 12 here. So 3 plus 12 is 15. So 7x plus 12 is your quotient and 15 is your remainder. So whenever the number 7 we are writing, immediately I adjust the quotient digit, same as multiplying. Whatever the process that we did, the same process we are doing it here. 7 into 1 we are doing, 7 into minus 1 is minus 7, we are adding it here as plus 7. And then 7 plus 5 is 12, because divided by 1, we don't observe that. Otherwise, it is the same thing. 7 plus 5 is 12, 12 into 1, 12 here adjusted, 3 plus 12 is 15. So 7x plus 12 is my quotient and 15 is my remainder, right? So let us take another problem in the similar direction. 7x square plus 5x minus plus 3 divided by 7x minus 2. Now we divide with 7x minus 2. So be very careful. When you are dividing the thing, you cannot pass the remainders. You have to exactly divide. So first 7 is divided by 7, correct? So if you want me to write like this, this will become very easy. 7, 5, 3 and 7 minus 2. And whatever the procedure that we had done previously, just go ahead, make sure that your remainders are 0. 7 is 7, 7 ones are 7. So always 0 is passed, so you need not write 1 into 2 plus 2, again 7, 1 plus 2, 5. So x plus 1 is my quotient and 5 is my remainder. So better way to do any problem is in this direction, excluding the variable terms here. Yeah, honors method, we call it as honors method of division. So that honors method only works whenever the x quotient is 1, but here our method works for any number, right? So even if it is 7x minus 2, our method works, right? So I hope you are getting this. So the same procedure without x, that's it. And then at the end, you keep on placing the x's, right? So let us take another problem. Here x cube minus 3x square plus 10x minus 7 divided by x minus 5. So because this is 1, an easy way to do is x square, 1 quotient here, so plus 5, which is 2x, 5 2s are 10, right? 20, and then 20 into 500, which is 93. So when 1 is there, directly you can do it easy way, means directly you can write it. But if you want with numbers writing like this, 1 minus 3, 10 minus 7, 1 and minus 5. So 1 we take, divide with 1. So plus 5 will go, 2 will take, 2 it goes again, because it is divided by 1. So 2 5s are 10, so it is 20, again 2 multiply with 5, 100. So although 1 goes 20 times, you exactly write 20 times. So this is my quotient, x squared plus 2x plus 20, and final remainder is 93, right? So I hope I'm clear with this. So let us go ahead with little next level sum, right? So where it is little bigger sum, let me take. I hope everyone is clear with this, right? So if at all any difficulty, please raise your hand so that I will manage my speed and I will reduce the thing or something like that, right? So it is x power 4 minus x cube plus x square plus 3x plus 5 divided by x square minus x minus 1. So better we write in this direction, which will be very easy for us. At the initial stages, I recommend 1 minus 1. All powers should be there. If it is some power is missing, you have to write it as 0. but all powers are there, so we can write it as 1 minus 1 minus 1. So 1 is divided by 1, 1. We have to add 1 and 1 here, right? Blindly write 1 and 1. So 1 plus 1 is 0, so 0, so 0, 0, right? So this is 2 here, 2. So here, so this is my quotient part, this is my remainder part. So 2, 2 will be added. So 3 plus 2 is 5, 5 plus 2 is 7. So 5x plus 7 is my remainder, x squared plus 2 is my quotient. So x squared plus 2 is my quotient and 5x plus 7 is my remainder. I hope everyone is getting this way, right? So blindly following only one procedure is very easy, but as you have to become little versatile in the sense that you could able to easily write x squared by x. So first one is multiplied and added, so it will be 0. So x is not there. So and then in the third term, 0 into 1. So you have to allow your mind to think in that direction and your answers will be there, right? So let me take to the next problem of the same type. It will be little big with numbers. 6x power 4 plus 13x cubed plus 39x squared plus 37x plus 45 divided by x squared minus 2x minus 9. X squared minus 2x minus 9. So when I'm dividing this, so 6, 13, 39, 37, 45 and 1 minus 2 minus 9. So either you can change here also or inside also, whichever way that is convenient for you, hardly matters. So some of the other place you have to change it, right? So you can take 6. So 6 is my final number. 6 2s are 12, 6 9s are 54, right? And then 13 plus 12 is 25. So you have to multiply with 25 directly. So 25 will come, 25 2s are 50, 25 9s are 225. It's going to be very big number. 100, 130, 43, 143. So 143 into 2 is 286 and 143 into 9 is minus 15 is 28. 1287, I think so. 1287. So although in front of me the answer is there, I am calculating and verifying. It is important that you have to calculate and verify. The more you do that, the more easier. Although in front of me the answers are there, but I am calculating every step on my own, right? And then, okay, if at all I go wrong, I can verify because I am teaching, right? So here just add the numbers. 4 plus 1 is 5. 8 plus 2, 10 plus 3, 13. So 43, 45, 53. Yeah, here you have to directly write it. So here the number is our number is 548, right? 548x plus 1287 plus 45 is 1332. Okay. So here x square plus x plus this thing. So although big numbers are coming, it is very important means that how you are adjusting that and multiplying the things and all. So generally these big sums won't come in the exam point of view if you see. Just for the sake of Vedic method division, complex divisions and all we are getting. Otherwise till 10th grade and 12th grade, most of the problems that you see, you will not get these big numbers and all. They will be much more simpler than this. Right? So here the next problem I'm taking here now. We can try with multiplication and taking this thing. Let us take one multiplication problem and then division problem so that we can finalize the divisions here, right? So let me take multiplication after that division so that it will be easy for me to take, right? So 3x square plus 5x minus 2 multiplied by 2x square 2x cube minus 3x square plus x minus 1, something like this, so that it will be easy for us. And then we can add something here, 3x minus 7, something like this. So anything if you take, you are going to get. So this is my dividend. I'm taking beforehand so that how I can solve easily, right? So here by multiplying and I'm writing the directly answer. 3 2s are 6, x power 5, 9 minus 9 plus 10. So x power 4, and then 3 multiplications, 3 minus 15 minus 4. Minus 15 minus 4 minus 19 plus 3 is minus 16. X cube, and then minus 3 plus 5 plus 6. 5 plus 6, 11 minus 3 is 8. 8x square, and then 5 minus 5 minus 2 minus 7x. Yeah, minus 7x plus 3x is minus 4x. And then 2 ones are 2, plus 2 minus 7 is minus 5. So mostly this will be my dividend, and I want to divide either one of this. So both we will try and see that how we are solving the problem. My number is 6, 1, minus 16, 8, minus 4, minus 5. I'm dividing with any one of these, you can pick it up, 3, 5, minus 2. Okay. So my number goes now. So here my quotient will be this and remainder part is this. So 3 goes 2 times, 3 2s are 6 and 2 5s are 10, 2 2s are 4 is adjusted. So minus 10 plus 1 is minus 9. So 3 3s are 9 and 3 into 5, 15. 3 into 5, 15. 3 2s are 6 plus 6 will become minus 6. I hope everyone is clear till this point. Right? Now 15 plus 4, 20. 19 minus 16 is 3. So 3 ones are 3. 1 into 5 minus 5. 1 into 2 plus 2. So 11 minus 8, minus 11 plus 8 is minus 3. So 3 minus 1s are minus 3, plus 5 minus 2. So 7 minus 4 is 3x, plus minus 7. Do you observe the same quotient we are getting? 2x cube minus 3x square plus x minus 1, right? 2x cube minus 3x square plus x minus 1. I hope I'm clear with this, right? There are no remainders. Always this is perfect divisions, right? If at all it is not divided, we will take the last one in the end. So I'm making erasing this so that I can write the next, the same step with the other part as my dividend. Yeah, this one also. So let me. I'm taking this. So here I'm taking this as my divisor. So 2 will be there. Minus 3 plus 1 minus 1. Minus 3 plus 1. Minus 3 plus 1 minus 1. So here my 3 digits are there. So 3 parts are gone. So this is my quotient part, this is my remainder part. So 6 I will take, 2 3s are 6, minus 9, so becomes plus 9, plus 3, so minus 3, minus 3, so plus 3. So 9 plus 1 is 10, the second position. Second position is 10. So 2 5s are 10, 5 3s are 15, so minus 15 means plus 15. 5 1s are 5, so sorry, minus 5 here, 5 into plus 1 is minus 5, minus 5 becomes plus 5. So in the next step, we are going to take the, so 16 plus 3, 19, minus 19 plus 15, so minus 4, so minus 2, so plus 6, minus 6, minus 2, plus 2, plus 2, minus 2. So 8 plus 3 is 11, 11, so gone. So nothing remains here, 0. So 7 minus 4, 3, and minus 2 minus 5 is 9. Right? So my answer is there. 3x squared plus 5x, sorry. 3x squared plus 5x minus 2 is my quotient, and 3x minus 7 is my remainder. The beautiness is here also we can apply the digital root technique. Let us see how to apply the digital root technique here. So if I am taking the digital root of this here, let me take with red color. So here 2 plus 1 is 3, minus 3 minus 1. 2 plus 1, 3 cancels, minus 1. Minus 1 is nothing but 8, because always minus cannot be your digital root. Add 9 to it, so make it positive. So 8 minus 2 is 6. 8 6 are 48. Here it is minus 4. Minus 4 is 5. So 48 means 3. 3 plus 5 is 8. So my final digital root should be 8. So anyhow, 9 cut. 6 plus 6 minus 6 plus 1 minus 1. 8 remains. So which is my correct answer? So I can say all the sides I can verify. So this is my division. Okay. So only thing is that if I'm taking the exact division, sometimes it may not divide, right? So it goes very complex way. For example, just I will show you one small thing. I won't take much time. I will take very short one, and then we will close this session, right? Suppose if my number is whatever, 2x squared minus 3x plus 5 divided by 3x minus 2, something like this. So 2 minus 3, 5 divided by 3 minus 2. So here 2 by 3 is my first one. You have to exactly divide. And then 2 into 2 by 3 is 4 by 3. So minus 4 by 3 becomes plus 4 by 3. So minus 3 plus 4 by 3 means minus 9 plus 4, which is minus 5. So which is minus 5 by 3. Here minus 3 plus 4 by 3, which is minus 9 plus 4 by 3, which is minus 5 by 3. Again, I am dividing by 3, which is minus 5 by 9. So here minus 5 by 9. I have to do this. There is no other go. When I am dividing, exactly it should divide. So if it is not dividing, I have to write exact divisible. That's it. And then when I am multiplying, 5 2s are 10. So here I am getting a positive, so I will get a negative minus 10 by 9. 9 5s are 45, minus 10 is 35 by 9. So this is my
Yes, sir.
2x by 3
minus 5 by 9 into minus 2. Hello, excuse me, sir.
Yeah. minus 5 by 9 into minus 2, which will be minus 10 by 9. Correct? And 5 minus 10 by 9 is same as 45 minus 10 by 9, which is 35 by 9. So 35 by 9 is my remainder. 2x minus 2x by 3 minus 5 by 9, which can be
Yes, I
also
think that's it.
represented as, which can be also represented as 2 3s are 6, 6x minus 5 by 9 is my quotient, and 35 by 9 is my remainder. Right? So this is the fractional division. Generally, we don't come across. If at all we are coming across, only the possibility is write it in fractions. Right? Because the decimals become 0.3333 and all, it will become difficult. So you can retain it as fractions, and fractions, addition, subtraction and all, the more you clear that you are in that direction, the more easier you can write the answer. Any question? So everyone can unmute. So if you have any questions, feel free to ask any question. Till now, almost the normal divisions along with algebraic divisions we have covered.
So can you please repeat the
Digital root?
last problem, the previous problem to this?
Yeah, to the previous problem. So whatever the digital root is there, actually I don't have the numbers. Okay.
Sir,
Let us take it, no problem. I will simply tell you, let us take 2x minus 3 into 5x plus 2 plus 4 is there. Suppose something like this. So my question will be 10x squared, and then minus 4 plus 15 is minus 11x, minus 6 plus 4 is minus 2. Right? So this is my dividend. So when I'm dividing with this by 2x minus 3, my quotient is 5x plus 2 and my remainder is 4, right? So if I want to find the digital root of this, I multiply these two. So 2 minus 3. 2 minus 3 is minus 1. Minus 1 cannot be digital root, so I change it to 8. And 5 plus 2 is 7. Here digital root is 7. And then here 4. 7 8s are 56. 56 is 2. 2 plus 4 is 6. 2 plus 4 is 6. So here if I observe minus 2, minus 3, minus 4 plus 1, minus 3. Minus 3, for this it is minus 3, which is same as 6. So my answer is correct. Just I'm telling, in between the steps and all are there that everyone can write on their own. But the beautiness lies always when you are writing in one step, right? So it is very, very important to write it in one step. Our means mind is very, very powerful, I'm telling. So here the dividend is equal to divisor times quotient less remainder. So when we are taking this, dividend is 10 minus 11 minus 2. So minus 11 is minus 1 and minus 1. Huh? Divisor is 2 minus 3. Quotient is 5 and 2. And remainder is 4. So we have to multiply this. Right? So here minus 4 plus 1 is minus 3. Minus 3 means plus 9 is equal to 6. So that's how it will be. Here minus 1 is 8. 8 into 5 plus 2 is 7. 8 sevens are 56. Plus 4 is equal to 60. So 0 take it out. 6 and 6 are mapped. So if at all any doubt is there, so always you can, I request you whenever you are having any difficulty, our group, you can take a pic of that and you can post it in the group. To the great extent, I myself or Charan or someone will generally, as early as possible, will come up with, right? So we can find out any difficulty.
Excuse me, sir. Ramesh sir, excuse me, sir.
Yeah,
సార్ 4/3 కి ఇప్పుడు మనం చేసాం కదా సార్ ఇంతకుముందు ప్రాబ్లం లో
yeah,
4/3
yeah.
మల్టిప్లికేషన్ కి ఒక ప్రిన్సిపల్ చెప్పారు సార్. వేదిక ఇప్పుడు మనం ఇంతకుముందు చేసాం కదా, డైరెక్ట్ గా మల్టిప్లై చేశారు కదా సార్.
అవునండి.
4/3.
Yeah, 4/3. Yeah.
4/3 కి ఆ రూల్ చెప్పారా సార్? అదేమన్నా ఇప్పుడు మీరు డైరెక్ట్ రాశారు, అది రెండు
I'm getting you.
తీసుకొని డైరెక్ట్ మల్టిప్లికేషన్ చేశారు కదా.
Okay, 1 second. I got your question. Right? So when 4/3 is there,
Yes.
right? So here 7 dots I am saying, right? So
Okay.
my answer will be in 6 parts. 1, 2, 3, 4, 5, 6. Okay, 4, 5, and 6. So you have to remember the pattern, that's it. So it is very easy. Either you go from right side to left side to right side. First what you are going to multiply this. Further you cannot go back, right? So this is the one. When you are going for the second one, you observe second and then one previous, right? And then you go to the third, you can come one previous, you can come two previous, right? And then this one and this one are over now. Now you have to start here. This, before and before. If you go in sequence, whatever the big number is there, now the third one is also over, the second one. Yes. And then the strike. So if my number is, let us say 3x square or 3x cube minus 2x square plus x minus 4 or minus 1, it will be simple numbers, times 2x square minus 3x plus 1. Something like this is there. So in the first multiplication I observe, this is 3 times 2. I write it and then I will erase. So this is 3 times 2, which is 6. So 6x power 5 I write. Okay. And the second step, I'm going to multiply the next one. 3 3s are 9, 2 2s are 4. I observe that minus 9 minus 4. I do it in my mind. Minus 9 minus 4 is minus 13. Minus 13x power 4. Right? And in the third case, let me take 3 into 1. The last one, 3 into 3 is over. 2 into 3 and 1 into 2. So here positive, positive and positive. So 3 plus 6, 9 plus 2 is 11. Are you getting? So 9 plus 2 is 11. 11x cube. Now with 3, all the multiplications are over. Now I will move on to next number, minus 2. So here minus 2, this one and this one. All three are minus. Minus 2, minus 3, minus 5, minus 2, minus 7. So my answer will be minus 7x square, right? We'll have, now 2 also is over, now 1. So this is 1 and 3. 1 plus 3 is 4. So I write 4x. And then last one is minus 1. So if at all I am addition with 3x plus 5, directly I will add here itself while writing 4 plus 3 is 7, 5 minus 1 is 4. I will write like this directly in the first go itself. I will not wait for the second go. In the first go itself, I will multiply, add the things, do the things that we are going to learn anyhow tomorrow. Tomorrow my session is all about multiple operations. So multiplication and division together, how we are doing. That is what combined operations is, right? So